Hi, my name is Jasmine Bianca Arsalis, and today I will be talking about the properties of matter, describing matter, the classification of matter, and the history of atomic theory. We all know that matter is anything that has mass and takes up space. But what about mass and volume? Mass is the measured amount of the material the object contains, while volume is the measured space occupied by the objects. Now, there are two main types of properties, physical and chemical. Physical properties can be observed or measured without having to change the composition of the matter. Examples of these are appearance, texture, color, odor, viscosity, melting point, boiling point, density, solubility, polarity, and many others. While chemical properties are properties that can be measured or observed only when matter undergoes a change to become an entirely different matter. These include reactivity, flammability, and the ability to rust. Describing matter. Properties used to describe matter can be classified as extensive or intensive. Extensive, such as mass and volume, which depend on the amount of matter in the sample. Intensive, such as density and color, which depend on the type of matter, not on the amount presented. Now let us proceed to classifying matter. Can it be physically separated? If so, it is called a mixture. If not, then it is a pure substance. A mixture is a combination of two or more pure substances in which each pure substance retains its individual chemical properties. If its composition is uniform, it is a homogeneous mixture. They are evenly mixed and consist of a single phase. If not, it is a heterogeneous mixture in which we can be able to see its different parts. Now, let's discuss about the history of atom, its theories, and its models. The theory originated as a philosophical concept in ancient India and Greece. The word atom came from the Greek word atomos, which means indivisible. Let's start off with Democritus. Democritus is a Greek philosopher who began the research for a description of matter more than 2,400 years ago. He asked, could matter be divided into smaller and smaller pieces forever? Or was there a limit to the number of times a piece of matter could be divided? His theory, matter could not be divided into smaller and smaller pieces forever. Eventually, the smallest possible piece would be obtained, and this piece he called atomos. To Democritus, atoms were small, hard particles that were all made of the same material, but were different in shapes and sizes. He states that the atoms are infinite in number, always moving, and capable of joining together. This theory was ignored and forgotten for more than 2,000 years. Why? The eminent philosophers of the time, Aristotle and Plato, had a more respected but ultimately wrong theory. They both favored the earth, fire, air, and water approach to the nature of matter. Now let's go about the models. Let's start off with solid sphere model by John Dalton. Dalton drew upon the ancient Greek idea atoms. His theory stated that atoms are indivisible. Those of a given element are identical, and compounds are combinations of different types of atoms. He recognized that atoms of a particular element differ from other elements, and atoms aren't indivisible, they're composed from subatomic particles. Plum pudding model by J.J. Thomson, 1904. Thomson discovered electrons, which he called corpuscles, in atoms in 1897, for which he won a Nobel Prize. He subsequently produced the plum pudding model of atoms. It shows the atoms as composed of electrons scattered throughout a spherical cloud of positive charge. Nuclear model. Ernest Rutherford, 1911. Rutherford fired positively charged alpha particles at a thin sheet of gold foil. Most passed through with little deflection, but some deflected at a large angle. This was only possible if the atom is mostly empty space, with the positive charge concentrated in the center, the nucleus. Planetary model by Niels Bohr, 1913. Bohr modified Rutherford's model of the atom by stating the electrons moved around the nucleus in orbits of fixed sizes and energies. Electron energy in this model was quantized. Electrons could not occupy value of energy between the fixed energy levels. Quantum model by Erwin Schrödinger, 1926. Schrödinger stated that electrons do not move in set paths around the nucleus. but in waves. It is impossible to know the exact location of the electrons. Instead, we have clouds of probability, called orbitals, in which we are more likely to find an electron.